Hey guys, welcome back to another episode of robotics. So today what we're going to do is we're going to do some of the challenges that I assigned you in the last video to kind of show you how that all works. And then we're going to go uh, an additional level with our driving functions. So let's go ahead and review what we did last time. So last time, looking at the code here, we added the variables for the pins, and then we created forward and backwards functions. Now, we added the speed parameter, which allows you to set the speed whenever you move forward and also whenever you move backwards. And one of the challenges was to add the capability to set two speeds. So let's say motor A goes slightly slower or faster than motor B, and so that when that happens, what happens is that when you move forward, it actually doesn't go perfectly straight. So what you want to do then is slow down motor A, and so in that sense, you're going to have different speeds for both motor A and motor B. Okay, so how would you do that? We would just add a second parameter here. So I'm going to say in speed, but I'm going to call it int speed A, because it's going to be speed A, and int speed B. Okay, so then now I just say for motor A, I'm not going to use speed because speed no longer exists. I just change it to speed A. And then motor B, down here, speed doesn't exist again. Now I don't want to do A because that's my motor A speed. I want to put B. And that's it. That's all we did. So what we did was you have to add a second int in the variable here because you have two parameters now, not just one, and it's separated by a comma. So the comma separates the two variables or parameters, and you're good to go. So let's try it out. So I'm gonna say I have this for loop here. I'm gonna take out the for loop. We don't need that. Okay. Now you see, let's say if I just said move forward at 100, okay? If I upload, I should get an error. Yep. See, it says too few arguments. Move forward. And it says int comma int. So that's a clue. It says, you know, right now you only have 100 in there, but it needs int comma int, meaning it needs two parameters or two numbers. Okay, so if you forget to kind of update everything, the compiler or whatever this thing is, whenever you upload the code, it goes through what's called the compiler. It will check, and if you have any errors, it will tell you, which we just saw. Okay, so let's say I go 100 and 255. So that means motor A is at 100 and motor B is at 255. Let's see what happens. I'm going to upload this. Oh, what happened here? Void, I'm missing. Oh, yes. This delay 100. Oh, and let's make it go 1000. So it's going to move forward for 1000 before it stops here. Okay. Cool. Okay. My video, here's my button here, and I'm just gonna hold it up. Okay, looks like motor B is going. Motor A is not going at all, maybe because 100 is too slow. Let me just put 255, just make sure it works. Let's try again. Okay, cool. So they both work. So it looks like 100 was just too slow, which I think we found out last time. So let's do like 150. Then what happens is that motor A, which is this one right here, should move slower than motor B. Let's try it out. Yep. And you can tell, because look, if this is slower, it's gonna veer off to the left, which it does. I don't know if you could see in the video. Let me try again. You see, it's kind of going off to the left. But then, if I set them both to 255, it should be better. Let's check that. If I set them to the same speed, it should go straighter. Let's check. Okay, I'm gonna move it back, and I'm gonna press the button right now. Yep, you see it goes straighter. Okay, cool. So now we have function for move forward. Let's do the same thing for move backwards. So int speed A, int speed B, and motor A is speed A, and motor B is speed B, and we're good. And I'm not going to bother testing that one. I'm pretty sure it works because I just made this minor change, so I'm not going to bother testing that one for now. Okay, so I have a move forward and a move backward. Let's have a turn left and turn right. Okay, so I'll start with the turn right, and I want to turn at 90 degrees. So that means if I want to turn right, that means I want to turn this way, looking at the camera here. And so that means this motor is stopped and this motor is going forward, right? And this motor is motor B. So motor B is stopped, motor A is going forward. Okay, so let's do that. Okay, so I'm going to say motor B is stopped. So then I'm just going to use analog right now since that'll be simpler so I don't mess up. Motor B pin 1, commas, I'm just going to use 0. Analog right, motor B pin 2 is 0. Okay, if they're both 0, it stops, right? And then motor A moves forward. Analog right, motor A pin 1. Now forward, which one is forward? Let's go to my, so move forward. Ah, it's like this. Okay. So this moves it forward because I'm looking at the move forward function here. I'm just gonna put this in there. Just copy and paste it. Now, oh, I like this. You can put the speed in there too. So kind of, you can determine how fast. Maybe I don't want that quite yet. I'll leave the speed part out. So analog right, and then we'll just say full speed, 255. Okay. Now here's the thing about turning. What happens is that the motor A has to move forward, but I only want it to move forward until it gets to there, where it's like 90 degrees, and then it stops. So we have to put a delay, and I'll try delay 700 for now. And then we stop motor A. Right? So we move motor A forward, and then we stop motor A. So I'm putting that in there. I'll do zeros. And then we're done. Okay? So let's test this out. Turn right. Okay, so when I press the button now, it should turn right. Now, the delay might be incorrect, but we will test it out and see what happens, okay? So I'm going to push the button now. Not bad. If you check it out. Here, it's actually, I got pretty lucky, actually. Okay, let's try again. I'm going to press the button. See, it's just overshooting slightly. I just need to just back it off a little bit. So maybe 600, going back to turn right. I think 600 will be good. Let's upload this. Pressing the button. Okay, I like it. Wow, that was easy. So now I'm gonna copy this and I'm gonna paste it down here because it's very similar. For turn left, it's just gonna be the opposite, right? So now that I pasted it in here, let's change all the opposite stuff. So for turn left, motor A is stopped, and then motor B moves forward, and then down here we stop motor B. Okay, so I changed my comments first. Now let's change this part. So motor A pin, motor B pin, and motor B pin. Okay, so let's double check here. Motor A is stopped. This looks correct. Now motor B moves forward. So motor, it's pin 1 255, pin 2 0. Let's make sure that's correct. Move forward. Oh, actually, no, it's flipped. So I went to the move forward function, and we see to move motor B forward, it's actually pin 1 should be 0, and then pin 2 should be the speed. Let's check that. Pin 1 should be 0, and then pin 2 should be the speed. And the reason it's flipped is probably because I flipped my wiring on this side, so it's not always the motor A and B could be flipped from each other to move forward. So just keep that in mind. Good thing I checked. And I wonder if 600 will work for turn left too. It might be different. We'll see. Let's upload. Well, let's first do turn left. Upload. Awesome. All right. Now let me try. Let me try again. Look, it's way off. So 600. I'm pressing. We're not way off, but it's not enough, right? So 600 was perfect for right, but turn left, it looks like it's not enough. Probably because the motors are going at different speeds, which we've talked about. So turn left. Where's my turn left? I'm gonna keep the speed same at 255. I'm gonna change this. So 600 didn't quite work. Let's do 900 for turn left. Again, your numbers will be a little bit different from mine. Cool. Trying again. Okay, 900, you see it went a little bit too far. A little bit too far. So maybe 800 is the magic number. Let's do 800 here. Try again. I think it's like a little bit too much, but like right about there. So I'm gonna leave that. It looks pretty good to me. I got so 800 for turn left and 600 for turn right. Okay, so that's great. Now let's go with today's challenges. All right. So the first thing I want to do is I want to be able to move forward, okay? Change move forward using speeds plus distance. What do I mean by that? I want to be able to just tell my robot to say move forward 1 inch and make it able to do that. Okay, so how are we going to do that? Move forward. So move forward is right here, right? And I'm going to say, because I want to also put in distance, so I need to put another parameter, int, and then I'm going to say inches. Okay? So what do I need to do? I need to say it's going to turn both these motors on, right? And then move forward inches, the distance in inches, right? Whatever I put here, it's going to move forward the distance, and then after it finishes, it's going to stop. So move forward, we'll just move forward, and then stop. Okay. Now, this part I know. How do I stop the motors? I actually have a function, I believe. Yeah, called stop, right? So why don't I just put that in here? That's easy. All right. So the one I don't know, which is kind of hard, is what do I put here? How do I move forward the distance in inches? Well, the thing is that once these 4 commands go, right? Once this section goes, the car will just start moving forward. And so all I really need to set is how long do I want to move forward. So I have to put some kind of delay here. But what do I put inside there? Question mark. Like, delay how long? Well, it really depends on the inches, right? So if the distance is longer, like if I put in 100 inches, your delay is probably longer, right? And if it's really short, like if I put 1 inch, your delay is going to be shorter. So we know that part, that much. So how do we, but we have to put some kind of, we got to do some math, I think, right? To know what to put into the delay. So I'm going to create a variable here, int my delay. Okay. And I'm going to just say for now, I'm going to say my delay equals 1,000. And then just put in my delay in here. Okay, so this is, I'm not really doing any math right here. I'm just saying I'm creating a variable called my delay and setting it to 1,000 and putting a 1,000 in there. Okay, so what does that mean? Is that no matter what happens right now, it's going to just move 1,000 forward and then stop. Right? So let's try. Let's put in here move forward, and I'm going to do 255, 255. So I'll keep them both motors the same speed for now, just as I'm testing, and I'll put in 1 for the inches. Okay, but really it doesn't matter what I put right now because it doesn't, because no matter what, because of my code right now, my delay is always 1,000. So we'll fix that later, but just for now, I just want to see if this works. So if I say move forward, it should just move forward for 1 second and then stop. So let's just make sure that that works. It should move. Okay. Okay. I'm gonna press my button here. It should just move forward for a second and stop. Okay, that worked. That moves really far, actually. All right, let me, instead of 1 second, let's do 500. Because it's almost running off my table, so. Okay. Let's try. Cool. Okay. So now it's going, when I press the button, it moves forward for 500 milliseconds and then stops. Okay. So why am I doing that? Well, let's do some measurements. We'll see. All right. So right now I put 500. So basically we know that it will move forward for 500 milliseconds, which is half a second. Now I'm going to put this ruler here, okay? I'm going to put it right at, I'm going to put the 0 mark right at the middle of the wheel, okay? All right. Right at the middle of the wheel. So now I'm going to press the button and I'm going to see how far it goes in half a second. Okay, pressing the button now. Okay, it has stopped. All right, so let me go look. If I look at it, it's right at about 7 inches. Interesting. 7 inches. Okay, so let's do some math here. All right, so now I'm taking a closer look. I just want to make sure I get this right. It's actually closer to 7.5 inches. And so that may make a difference later. So I want to get it as exact as possible. So mine, at 500 milliseconds, it goes 7.5 inches. So we're going to do a proportion here. You may not have learned this in the past, but I will just kind of follow what I do. And that's the cool thing about doing these kind of things in robotics, is that we can learn math, and there's an exact, sometimes you ask, why do we need to know this stuff? Well, we're going to learn proportions so we can learn how to write this awesome function for our robot. Okay, so we said we moved 7.5 inches, and that, I'm drawing it over 500 milliseconds, right? So that's what we found when we did our test here. Now what I'm trying to find right now is I actually want to find how many milliseconds does it take to move 1 inch, because once we know that, that is the thing that we need to finish our function. So all you got to do is say equal to, and you put up here, like, what is it? What's the distance you want? You're looking for 1 inch. And then I'm going to use a variable x. So x is a variable, and once we figure out x, solve for x, that will tell us how many milliseconds we need to move in order to move 1 inch. So how do we do that? We're going to move the x over here. So 7.5 x equals, and this 500 milliseconds can go up there, 500. Okay, and then we can divide x equals 500 divided by 7.5, which equals, and I can't do that in my head, so 500 divided by 7.5 is 66.6. Okay, cool. So now we know, through our tests and through this proportion equation, we see that 66.6 milliseconds is what is required to move 1 inch. So let us test that. Okay. So if I change this to 66, I can't do decimals with an int, and that's fine. We'll just leave it at 66, close enough. I should move about 1 inch on my robot, so I'm gonna put it here, okay? And I'm gonna upload, and I'm gonna see what happens here. Okay, pressing now. And what do I have? I have, seems it might be, oh, there we go. It moved about 1 inch. Cool. Perfect. It moved 1 inch, so it's actually pretty good. Okay, so now I know that 66 is what it takes to move 1 inch. So now, what do I do with this? Well, whatever the person puts, right? Let's say you put in 3 here, then you would say the delay would be 3 times whatever this is, 66. That would give you 3 inches. Okay, so how do I change this? So my delay is actually going to be inches times 66. There we go. Okay, so let's say I put in 1 inch, then it'd just be 1 times 66, and then we already tested that. That worked. If I put 2 here, 2 inches, it would be 2 times 66. So my delay would be 2 times 66, which would be 132, and then it should move 2 inches. You just keep multiplying like that. And the key here was you found out what's the delay for 1 inch, and that's why you're able to do this simple multiply thing. Now let us test. So move forward full speed at 1 should move 1 inch. Let's make sure that that still works. Perfect. Let's go 2 inches and see if our formula is working. It's kind of weird. I don't know why it overshot. I think the first time that I did that, I'm gonna have to look into why it's doing that, but I think it should be better. Yep. So the first time it kind of overshot. Don't know why. But it goes, is it like it's almost 2? Let's see here. Okay. So it looks like 2. Here, let's try 3. It's kind of giving me some unexpected behaviors, but that's okay. Let's do some testing here. So this should be about 3 inches. Try again. Okay, it's close. And then it goes far like that. Let's see what's going on here. Because now it's moving like 5 inches consistently. But it should be at 3. So what's going on here? Because inches. Okay, let's go back to 1. So we'll try to figure this out together. Okay. So 1 seems to work pretty good. Yeah, 1 seems to work pretty good. But then when I do 2, so let me just change it in my code here. My delay is inches. So for example, if I put 2, which would be 132, right? I'm just gonna hard code 132 in there. Should be about 2 inches. And it's actually going about 3 inches. About 3.5. Interesting. So about 3.5 there. So, and then when I go 3, it goes about, maybe what's going on here is that this number here is a little bit off. So this is like real life, right? We put in, we calculated 66. It looked pretty good for 1 inch, but then now we see that when we put it into the formula, it's not quite working like we want. So I'm just gonna back this down. I'm gonna make it 50 to see if we get a little better result. Okay. So right now it's for 1 inch. We're moving at 1 inch at 50. And it's actually good for you guys to see this because sometimes theory and the actual thing doesn't always match up. But let's see, but we can kind of, but once you start doing it, you can kind of play with it to get it to match. Okay. So 50, it's interesting, is like 2 inches. You know what? You know what I think? Let's see. Actually, let me just reduce this a lot and see what happens here. 20. Okay, now it's at 20. It's still, so it overshoots sometimes. Let's go even less. Let's go 10. And it could be that the motors are just going so fast that it's kind of inconsistent. Like if maybe you slowed down your entire car, it might work a little better. But let's see. Okay, so I try 10 now. And seems better. It's interesting when I do 10 versus 50, it's kind of all, I wonder just what happens if I put 1. So I'm just saying 1 millisecond is 1 inch right now. Seeing what happens here. So I think what's happening is that the motors are going super fast, and so that's what's causing it to, that we're not getting a good kind of test like data here. So you know what, I'm gonna leave that challenge with you then. So you kind of saw the process here, but it didn't quite work out that well for me, I think, because the motors are going too fast. So what I would do is, because look, moving forward, I did 255, right? What if I changed it to 150? Maybe because it's slower, I can get some better, some better data with that. So basically, try it at a slower speed and see if you can get a better calculation for the delay for 1 inch. And then once you have that, then you can do the rest of what we did over here, doing this part, because the formula and everything will be the same. Okay, so that's the process. I showed you the process. Now, I didn't work that well for me because I think it's going too fast. So your challenge now is to try what I did, but do it with your car going slower, and you might have some more success. Okay, so the goal would be to have a function move forward where you can just put the number of inches, and it would go consistently to whatever inch you put in there, whether move forward 10 inches and stop, 5 inches and stop, 100 inches and stop. You guys can play with that. Okay, so this will be a good challenge for you this week. I look forward to seeing how it goes. All right, take it easy.